We're going to look at adding and subtracting rational expressions. To do this, we have two different cases. So the first case is where we have what's known as like denominators. We're going to add or subtract fractions that have the same denominator. Numerically, an example would be 2/9 plus 5/9. 2/9 and 5/9, we're adding ninths, so all together we just add the 2 and the 5, and we have 7/9. So our answer is 7/9. We're now going to do this with algebraic fractions. So for example, I might say, let's add x over x minus 5, and we're adding to that 9x minus 3 over x minus 5. Because these are the same denominators, I'm going to work this problem horizontally. So I'm going to put the x minus 5. And because they're the same denominator, we just combine the numerators. We combine like terms. 9x and x is 10x and negative 3. So the fraction we get is quantity 10x minus 3 over x minus 5. But sometimes there's a problem with these. There's an exercise where we think they may not be like denominators, and they are. For example, we'll look at the problem x over x minus 3 plus 12 minus 3x over 3 minus x. At first, we look at this and we realize 3 minus x isn't exactly the same as x minus 3. But 3 minus x can be converted easily to x minus 3. We rewrite 3 minus x as negative 1 x minus 3, because that'll give us negative x, and minus times a minus plus 3. Now I'm going to do a rewrite. So I'm going to rewrite this as x over x minus 3 plus, and now I'm going to take that negative 1 and put it up above 12 minus 3x and over x minus 3. I just took this negative and put it above. Now I have the problem x over x minus 3, and then I'm adding to it. I'm going to distribute the negative 1 through. Negative 12, negative times a negative, plus 3x over x minus 3. We now have an addition of fractions with the same denominator, so I'm going to work it across horizontally. I put the same denominator here. Now I can just add the numerators. X plus 3x is 4x, and then I have minus 12 and negative 12. At this point, I realize I've got the answer, but I look at this and I realize I tried to reduce. So to reduce, we always factor if we can. So we can factor a 4 from the numerator, and that gives us x minus 3. And the denominator's already factored. So now I reduce. So this addition problem just gave us the number 4. The key here is that when you have an expression around a negative, we had a minus and a minus here. When you switch around a negative, it introduces a negative 1, which will go up above, and it's going to change the numerator of that other fraction. We're now ready to go to the second case, and our second case is going to be when we have unlike denominators. And with unlike denominators, it's when two denominators are not the same. Working an example numerically, so for example, if I said 2/9, and then I added to that 7/12, we want to add those two fractions. What I like to do as a first step is I like to write it vertically. So I'm going to write it like this: 2 9ths plus 7 twelfths. We now have to come up with the lowest common denominator. We need the LCD, the lowest common denominator, because that's going to go here, and that's what's going to allow us to build our fraction. In order to do that, we have 9, which are the prime factors 3 and 3, and 12, which is 2 times 2 times 3. So to get the lowest common denominator, we take each factor the most number of times it occurs in any one denominator. So 2 occurred twice here, so I use it twice. 3 occurred once here, but twice here. So because it occurred twice in one of the denominators, we move it here. So that gives us that our LCD is 2 times 2, 4 times 3, 12 times 3. Our LCD is 36. I'm going to put 36, our LCD, down here. We now have to build the fraction. So I think what times 9 gives me 36? 4. So I'm going to multiply 2 times 4, which gives me an 8. And similarly, what times 12 gives me 36? 3. So we multiply 7 times 3, and we have 21. The way we get now the answer is we've got 8 36 and 21 36. So our answer will be 36. 8 of them and 21. So our answer is 29 36. We're now going to do this with algebraic fractions. I want us now to add these algebraic fractions. We have 4 over the quantity x minus 2 plus 3 over the quantity x plus 1. My first step is I'm going to write it vertically. 4 over x minus 2 plus 3 over x plus 1. And I'm doing this because this allows me to write it so I can next build the fractions. So in terms of my steps, first step is I write it vertically, which I have done. Now I need the lowest common denominator to put for these new fractions. So I need the LCD. The LCD for these is going to be quite easy because we just have one factor, x minus 2, and then we have the other denominator, x plus 1. So the lowest common denominator will be one of each. And one of the things that I like to do, I'm putting the LCD here, is any quantity in the denominator that cannot be factored, I like to put in parentheses. Now our next step, we're going to build the fractions. So we're going to build the fractions to the same denominator, to the same LCD. The first one, we see here that x minus 2, we need quantity x plus 1. So we're going to multiply top and bottom by quantity x plus 1. Now what I like to do is actually distribute through. So I multiply 4 times x plus 1 and I get 4x plus 4. Now looking at this, I need the quantity x minus 2. So I'm going to multiply 3 times x minus 2 and I'm going to distribute, and that gives me 3x, and 3 times negative 2, negative 6. We're now ready to add the numerators of both of those fractions because they both have the same lowest common denominator. They're like denominators. Our answer will be, it'll have the x minus 2, x plus 1, but now we have 4x and 3x, 7x, positive 4 and negative 6, negative 2. So our result will be that. And of course, we always try to reduce, but 7x minus 2 cannot be factored, so it will not match the denominators. We're now going to do another problem which has got a little more to getting the LCD. We're now going to do a subtraction problem. We're going to subtract this fraction, x plus 2, over the quantity x squared minus 5x plus 6, and we're going to subtract from that the quantity x minus 4 over x squared minus 9. First step, which is important, it makes more sense with subtraction. We're going to have to put the numerator when we're subtracting in parentheses. I'm now going to do a rewrite because we can see here my first step is to write the problem vertically. So I have quantity x plus 2 over x squared minus 5x plus 6, and I'm subtracting x minus 4 over x squared minus 9. Now, one of the things we'll notice is that second step is we have to find the lowest common denominator, so that's going to require that these get factored. So this is x minus 2, x minus 3, and this is x minus 3, x plus 3. In these kind of problems, to get the lowest common denominator, usually there's one factor that is shared in both denominators. So actually, I'd like to rewrite this so that my original problem vertically will have these factors. I now have this subtraction problem, and now I'm getting ready to put the LCD. My second step is to put the lowest common denominator. So one of the denominators was x minus 2, x minus 3. The other denominator was x minus 3, x plus 3. So the LCD is going to be each factor the most number of times it occurs in any one of the denominators. So we have 1x minus 2. We've got to have 1x minus 3. It doesn't matter that it's in both. It only occurred once. So we put it once. And then we have x plus 3. So those get put here. X minus 2, x minus 3, x plus 3. X minus 2, x minus 3, x plus 3. We're now ready to build the fractions. We can see that these two are missing quantity x plus 3. So we're going to have x plus 3. And it's a good idea to have the original x plus 2 in parentheses. This requires us to FOIL. So we're going to get x squared, 2x and 3x, plus 5x, plus 6. We now build the second fraction, and that requires an x minus 2. So we're going to put an x minus 2. Now for this one, because we have the minus here, I'm going to FOIL, but I have to put the minus first. So I have to FOIL. And foiling this, I get x squared minus 4x minus 2x minus 6x, negative 4, negative 2, plus 8. We're now ready to combine these numerators. And this is going to take an extra step. Our answer is going to have x minus 2, x minus 3, x plus 3. In the numerator, we have x squared plus 5x plus 6. We've got these 3. And now we distribute the negative through, and we have negative x squared, negative a negative, plus 6x, negative times a positive, negative 8. We're now almost ready. We've got that same denominator, but now we're going to combine the terms in the numerator. So we have x squared and negative x squared. Those are 0. 5x and 6x, 11x. Positive 6 and negative 8, negative 2. We now have our answer. And we can see that 11x minus 2 does not factor, so it would have been in parentheses, and it is not going to cancel with any